So this unit is on exponential functions. So we did linear functions. When we graph a linear function, it is a straight line. An exponential function is a line that's going to curve. It could go the other way as well, going like downwards like that. But it starts off like relatively flat and gets so it's relatively steep by the end. So let's start looking at this. If I've got a piece of paper, we're going to say the piece of paper is approximately 0.005 inches thick. Paper, somewhere right around that range. If I take the piece of paper and I fold it in half, how thick would that be then? 0.010. Yeah, so we'd have 0.010. All right, so then we fold it in half again. After we fold it in half a second time, how thick would it be? 0.020. And then if I fold it a third time, 0.040. So what's happening to the thickness each time? It doubles. So I'm just going to put times 2. All right, so let's pretend we can have unlimited folds of this piece of paper. Take a second or two and see how many folds it would take to fold a piece of paper so it would be thicker than the height of the Empire State Building. Empire State Building is about 17,448 inches. Robert, what you got? 22 folds would be correct. So at 22 folds, we're going to be at 20,971.52 inches. So that would be thicker. 21 folds, it was only around 10,000 inches, so that would not be thick enough. Oh, I don't know why I wrote 20. My bad. 22 is the correct answer. Okay. Now, that's not physically possible, really. Like with a regular piece of paper, typically you can fold it 7 times. That's it. They've done, like, the world record is taking like a piece of toilet paper, like a huge sheet of toilet paper, and they could fold that in half. I think it was 12 times. That requires it to be like, extra thin, the paper to begin with. Show Mythbusters, they've done it 11 times. They used a piece of really thin paper that was like the size of a football field, and they were using like forklifts and steamrollers to make it like flat and stuff. So 7's not like exactly, but you are folding a piece of paper in half yourself, you're only going to be able to get it in half about 6 or 7 times. So when we have an exponential function, this is how they look, give or take. Sometimes you don't have all the parentheses with it. So we'll have, our function of x, our f of x there, and it's going to have some number. So a lot of times the initial value does not have a parentheses on it. Then the rate usually will go in parentheses, and the x is going to be an exponent. Even sometimes the rate won't be in parentheses, they'll just have like a multiplication symbol. So on your calculators, let's do this. Our piece of paper was 0.005. All right, so that's our initial value. We're going to just do multiplication. So you got 0.005 times our rate. Since it was doubling, it's like I put here, it's going to be times 2. And then to get our exponent on these calculators, you hit that little triangle-like button above the division symbol. And you can put your exponent in, then you hit enter, and you can see how that gives you that 20,971.52, right? Everybody good with how to enter those in?
Oh, wait, I have to put the triangle thing on this.
It all gets entered in one line, one row on your calculator. Calculator does the math in order for you. If you try to do it separately in pieces, you will get something very wrong. Okay? All right, so for exponential functions, there's two main types. You can have growth or decay. All right, an exponential growth function is getting bigger. Hopefully that would be obvious. If something is decaying, it is decreasing, it's getting smaller. All right, so if you have exponential growth, your rate, that number in the parentheses with the exponent on it, needs to be greater than 1. So ours was doubling when we folded the paper, that's growth. As I said, that means it's increasing. And if we took a graph of it, that's where it starts flat and curves up very quickly, very rapidly. Decay then. You have a rate that is less than 1. So the number in parentheses is less than 1. Or your exponent is a negative. So if like we had negative x as our exponent, that would be decay. Obviously, decay is decreasing. And the graph is essentially the same thing, just flipped left and right. It starts off really high and steep and decreases until it kind of flattens out. And these do always kind of reach a point where they flatten out and they don't go any lower than a certain number. We got it. All right, so just looking at a couple functions here. Start with this one. I have f of x equals 123 times 0.45 to the x power. So who could tell me what is my initial value here? Kari? 123. So initial value, 123. All right, what about, is this growth or decay? JJ? Robert? It's decay. All right, how do we know it's decay? We look at the parentheses here. We got 0.45. Is that less than or greater than 1? That's less than. If it's less than, we got decay. All right, now here's a tricky one. Our rate of growth and decay, or decay. All right, so we got that 0.45 there. That 0.45 is what we use in the equation. If it is a decay, that rate or that number there is subtracted from 100%. Think of it as like a percentage, okay? So our A is actually going to be 55%. Okay? Anybody not sure where the 55% comes from? So if it's decaying, we take it like we had 100% and we take the 0.45 and we are subtracting. Everybody follow? Any questions on that? I mean, you could do it without the decimals if that makes it easier for you. Just that's how it's working, okay? All right, so let's look at a different one. Initial value. Sorry. Initial value is 45. Is this growth or decay? Kyle. Growth, how do you know? Yeah, we got a rate higher than 1 there. All right, now, using what I said last time, who thinks they can give me the rate, the growth rate here? Sydney? Ford? Yeah, 23%. A lot of these are going to be percentages we're going to use for most of these. So when we're looking at this, that's like 123%. When it's a growth one, when it's over 100, what we're doing to get the rate is we are subtracting the 100 from it. So 123 minus 100, we got our 23% for our rate. All right, so if we got to write a function from a word problem, we've got Dre here is buying a car for $15,000. He's told that each year the value of the car depreciates by 8%. We need a function of the car X years after you bought it. Yo, this is actually going to be fairly easy to do. You take the initial value. The initial value is what he bought it for. That goes first. In our parentheses, what we're looking for, we have to decide if this is an increase or a decrease, growth or decay. So is this growth or decay? Decay. If you don't know, we got depreciates, starts with DE. That's usually going to be a decrease if it's starting with like got a prefix there like that. All right. So we are decreasing. Also, you know, if you buy a car 2 years later, it's worth less than when you bought it. That's how those things work. So when it's decreasing, what we do is we subtract from 100. So 100 minus 8 is 92. I write that as a decimal. So I would have 0.92. X is my exponent. Any questions on that? Everybody kind of follow? All right, let's try this one. We need the function for an account that starts with $500 and an interest rate of 6%. Who thinks they can give me the function? Olivia? All right, so our initial value is 500. In our parentheses, we are increasing interest rates, increase. So we would add to 100. So 100 plus 6 gives us 106. We got to put that in as a decimal though. So when we put it in as a decimal goes there. So we got 1.06 in our parentheses. And we got x as our exponent. Okay? So the big key each time is figuring out if you're increasing or decreasing. If you're decreasing, you subtract that percentage from 100. If you're increasing, you add it to 100. And then you got to convert to a decimal. Okay? All right, so a little trickier. We got Alice. She's 5 feet tall. She's eating some that magic cake they have. For every ounce she eats, her height doubles. So now we need function here. All right, so who's got a function for me? Sydney? So we got 5. That's her initial height. Her height doubles. So our rate, we're multiplying by 2. Similar to our paper folding earlier. Just instead of the thickness of the paper, we got her height at 5 feet. Okay? All right, so let's try these 4. You got to just identify if it's growth or decay. So first one here, top left. Sydney. That is growth. Top right. Lacey. That is decay. Bottom left. Levi. Nope. Robert. That is decay. Robert, can you tell us why that's decay? Yeah, we got a negative exponent. And bottom right. Pedro. That is growth. All right. Any questions on any of those? For the most part, whether you're identifying growth or decay, you're looking at the rate there in the parentheses. You do have to be careful every so often. They will mix in a negative exponent, but that doesn't happen a whole lot. Typically, you won't see those. All right, so then we got problems like this. So we start an account with $2,500. We got an interest rate of 6.5%. We need to know how much money is in the account after 7 years. So who thinks they can give me that answer? Now, this is a good example of how a lot of these work out. These are money numbers, but you don't always get money number answers. Just like if you're talking about people, we don't always get people answers. So there is a lot of times some rounding necessary. All right, Levi, what you got? Wait, say that again.
No, that's $66,800.
I'll take that.
I have it right.
All right, so we would have $3,884.97 with some rounding there. Y'all, the first thing you have to do, you have to get your equation. If you don't get the equation correctly, you're not going to get the answer correctly. So our equation, we take our initial value, the 2,500. Our rate, we got interest rate of 6.5%. Y'all, 6.5% when it's increasing is going to give us 106.5. When we change that to a decimal, we're moving the decimal 2 spots over. So we got 1.065. And then we would have X on it normally. Since it's asking after 7 years, all you're doing is the X comes out and you would put a 7 up there, and that would give you our 3,884.97. Any questions on that?